Right, welcome to a short presentation looking at strategies for addition. Right, students need to be aware not only of the symbol, the plus sign, but also of some of the common terminology used when we're talking about addition. We might talk about joining numbers, about the sum of numbers, about 6 and 5, meaning 6 plus 5. Use add, find the total, plus, together, combine, tally, how many and all. So language is important. They need to be able to recognise the words which are giving them the clue that addition is the operation under consideration. Of course, we've got to start with concrete materials, and we could be using Uniflex blocks. To add them up, we go from concrete materials to pictorial representation. There's another way of writing 6 plus 3, drawing little diagrams. We need to use the language, 6 and 3 makes 9, and leading of course into the abstract, the mathematical symbols, using the plus sign and the equal sign. So all of these contexts need to be used side by side so the students can associate the terminology with concrete materials. They can picture what's going on. There are a number of useful tools, mathematical tools that can be used. We can use disks and counters, Unifix blocks. We can use number lines, very, very useful. Whether you're adding or subtracting or skip counting and multiplying, number line is particularly useful. And of course a beam balance. We do tend to write things horizontally because it uses up less space on the paper, but we want to use also the vertical form because this is important when we go to teach the algorithm and adding numbers with more than one digit. We need to write them down one under the other with the units under the units, the tens under the tens, the hundreds under the hundreds, and so on. So we'd write the 4 under the 3. 4 and 3 give you 7. We've got the answer, the sum of 7. There are many strategies: counting all, counting on, counting from the larger add end. It's much easier on a number line to begin with the larger number and add on the smaller amount. Early on, there's nothing wrong with students using fingers to aid in counting. We want them to be able to spot the tens, look at the partners' numbers, they're often referred to as the rainbow numbers. Recognise doubles and near doubles, skip count by tens, be able to use known facts to work out other additions. If they know that 4 plus 3 is 7, 4 plus 5 is just 2 more than that, so 2 more than 7. Count on from 7, 8, 9, the answer is 9. Of course, if students realise the commutative property holds for addition, then of course it almost halves the amount of number facts they need to commit to memory. If they know that 7 plus 2 is 9, they also know that 2 plus 7 is 9. Often referred to as turnarounds in the primary school. More formally, it's called the commutative property of addition, that any two numbers added together, the order doesn't matter. 4 and 5 are 9, 5 and 4 are 9. A lot of the early work, of course, needs to be done using concrete manipulatives. We can use paddle pop sticks, modelling 47 plus 36, and the students can see that out of these ones, the 7 and the 6 give you 13. We can bundle 10 of these together and put it over in the 10 spot. So it leaves 3 in the ones, and when we're adding up the tens, we've got 30, 40, and we had that extra 10 that we carried over from the ones. So the answer is 83. There's another example taken from the textbook by Booker. When you're adding 24 to 68, 4 and 8 make 12. We've got 2 left in the ones, and we'll bundle 10 of those ones together and put it over in the tens column. Now when you go to add the tens, we were adding 24 and 68. Well, the 20 and the 60 make 80, and the extra 10 we carried over makes 90. So 68 and 24 is 92, or 68 plus 24 equals 92. We can move on from bundling sticks, paddle pop sticks, to using MABs. And of course this is more useful when we're looking at 3 and 4 digit numbers. So an example given here is adding 473 to 269. The 3 and 9 make 12. We'll leave 2 in the ones column and carry over those extra 10 into the tens column. You had 60 and 70 and another 10. So that is 14 tens, or 140. We'll put down the 4 in the tens place and carry the 100. In the hundreds column we now have 200, 400 and another 100 is 700. So 473 plus 269 equals 742. Very useful, always looking at playing games for students, get them engaged. A useful strategy when you're playing with cards, of course, is to use partner numbers, numbers that add up to 10, often referred to as rainbow numbers. So when we're going to count these numbers, we'll just organise them. That the jacks and queens are worth 10, ace is worth 11. So you've got the jack is 10, the queen makes 20, ace and a 9 makes another 20, so you got 40, 3 and 7 are 10, that's 50, 4 and 6 are 10, 60, another 4 and 6 are 10, 70, and then the remaining ones, 7 and 7 are 14, 2 are 16, 2 are 18, 2 are 20, we've got the sum as 90. So it's a useful strategy that can be used for addition, and useful concrete materials in working out these additions, actually using cards. Right, so although a lot of our early work is using bundling sticks and MABs and playing cards and number lines and beam balances and all sorts of tools, eventually we want to get to the stage where students can picture this in their mind and work these out in their head, mental computation. Often they won't have a piece of pen and paper to be able to write something down. They won't have a calculator to use. Recent research has shown that 85% of calculations that go on every day throughout the country, people are doing in their heads. So we're looking at thinking strategies. We'll consider 46 plus 23. There are a number of different ways that we could go about this. One way is to step to the next 10. 46 to go to the next 10, which is 50, I'd need 4. Right, I've taken 4 away from the 23, I've got 19 more to go. So altogether 46 plus 23 becomes the same as 50 plus 19. And we get the answer 69. Now it's not always how everyone will think, but this is one strategy we could use for mental computation without having the concrete materials to use or a pen and paper to write these numbers down to work out an answer. A second strategy is to jump tens, jump ahead by the number of tens. So we're adding 56 and 36, let's jump ahead 30 from 56, and we've got 86. Students would have done, of course, a lot of work using the 1 to 100 chart up on the wall, and realise that when you go down the chart it's going up by 10 every time. When you go right across horizontally it's going up by ones. So they've recognised that 66 is below 56 on the 1 to 100 chart, 76 is below that, and 86 below that. Jump ahead, 56 jumping ahead by 30 gives you 86, and then adding on another 6, well, another 4 makes 90, and you've got another 2 makes 92. So another strategy that we can use. Jump further. Think about 45 plus 29. 29 is almost 30. So let's jump ahead 30 from 45 to 75. We've gone one too far. 30 was one more than 29. So take one away from 75 and the answer is 74. A common one, of course, is to add the tens and add the ones separately. 25 plus 57, well, 20 and 50 make 70. 5 and 7 make 12. So altogether you've got 70 and 12. The answer is 82. So there's no one way that's better than another, and you'll find that different students will have different preferences. But in helping to develop their number skill, we ought to look at a number of different strategies. Not only teach the standard algorithm, but give them ways that they can work things out in their heads to prepare them for what they will be doing in everyday life. Right, can you add 53 and 28 using each of these four strategies? Feel free to pause the video clip if you wish, and then come back to it to look at the answers. When you step to 10, we'd need 7 to add on to 53 to make 60. Right, I've taken 7 out of the 28, there's another 21 to go, so the answer is 81. Jumping by the tens, well, 28, jump 20 from 53 gives you 73, another 8, well, another 7 makes 80, another 1 makes 81. Jump further, well, let's jump 30 from 53, that's 83, but that was 2 too many. We really want to add 28 on, not 30, so take 2 away from 83, and the answer is 81 again. The answer remains the same no matter what method we use. There are different strategies. Some people will prefer one over another. Adding the tens, 50 and 20 make 70. Adding the ones, 3 and 8 make 11. 70 and 11 make 81. That concludes this short vignette on addition strategies. Thank you for your attention.